Oh my gosh, guys, look at what this is. A heavy, beautiful cross that shines like gold. I haven't even polished it yet. To be honest, it is not pure gold. Its material is Nordic gold, cast by me myself. God, I like this cross so much. It is not just a symbol or an artifact. It is my firm belief. Hello everyone, thank you for watching my video. Today we're going to talk about Nordic Gold. Maybe you're wondering, what exactly is Nordic Gold? I brought this description over from Wikipedia. Nordic Gold is a gold and copper alloy used in three denominations of euro coins: 50 cents, 20 cents, and 10 cents. It was also used in other countries for several years, with the Swedish 10 krona coin being the first to use Nordic Gold. Its composition is 89% copper, 5% aluminum, 5% zinc, and 1% tin. Despite its name, it does not contain gold, and its color and weight are completely different from pure gold. Hypoallergenic, antifungal, weakly antibacterial, and anti-stain. So if we cast Nordic Gold ourselves, how do we do it? It's not difficult. First, we need to fill in the raw materials. If we use brass directly, then things will become relatively simple because brass itself is a compound of copper and zinc. Then we add the tin element, and the most readily available raw material is the tin wire used for soldering. Now don't forget to add aluminum. You can easily get aluminum from cans or aluminum foil, aluminum baking sheets, etc. After adding the metal raw materials, it would be perfect if you could add some borax at this time. This will make it easier for you to remove the waste residue. Now we can harvest metal. Remember, wear protective gear, operate with caution, safety first. The Nordic Gold solution will appear red in color, looks like pudding, and looks very elastic, but its temperature is as high as over 1000 degrees Celsius, making it very dangerous. Even after leaving it for 10 minutes, it will still be very hot, so be sure to use a grabbing tool and operate carefully. This is my entire process for making Nordic Gold. As for the proportion control of metal elements, I can only make a rough estimate, and it is difficult to accurately grasp it. Each metal raw material I use has an uncertain proportion of elements. I can only make sure that they are actually in it. I will try to improve my technical level as much as possible, but as a personal hobby, I think this is enough. In fact, I also did 2 experiments during this period. The first was to use plaster to carve models and try to make a cast bronze mold. Some people say that plaster will explode when heated. I want to try it. I carved the devil's eye out of plaster, let it dry for 3 days, then placed it on play sand and copper casted it. Guess what? The plaster didn't explode, but it boiled. Water vapor dialyzes out from within the plaster. I found the chemical formula of gypsum from the internet. Its chemical name is calcium sulfate dihydrate. Water is combined in the molecule. If you want the gypsum to not produce steam when heated, you need to heat the raw gypsum to 163 degrees Celsius to make it inert. Water plaster will do. The melting point of anhydrite is 1450 degrees Celsius, so it can be used as a heat-resistant model. But be sure to heat it up. Another experiment was to use cement to make molds. It had been discovered that cement slabs explode when heated, so I made a mold out of cement to experiment with. As a result, the cement mold also generates steam and boils. This cement mold has been drying for about 2 weeks, but because the chemical structure of the material is very complex and water molecules may solidify in various places, it is not recommended to be used as a raw material for copper casting molds. There was no explosion, just poor cement choosing skills on my part and good luck. Okay, that's all for today. Thank you for watching. Finally, I end this episode with my AI villain. Please click to subscribe and see you soon.